In this problem, we have a 65 kilogram skateboard that jumps from the sidewalk onto a 5 kilogram skateboard at rest. If the velocity of the skateboarder is 4.3 meters per second to the east as he leaves the sidewalk, what is the final velocity of the skateboarder and the skateboard? Whenever we have a collision, you might not consider this to be a collision per se, but whenever we have a collision, we want to think in terms of conservation of momentum. And so we're going to write a before and an after picture and write our givens as such. So in the very beginning, we have a skateboarder that is moving and a skateboard that is not, that is at rest. And afterwards, we have the skateboard and the skateboarder moving together as one. We are given that the mass of the person, I'll label it as MP, is 65 kilograms. The mass of the skateboard is 5 kilograms. We're given that the velocity in the beginning of the person is 4.3 meters per second. And the velocity of the skateboarder the skateboard in the beginning, is 0 meters per second. It's not moving, so I didn't draw any motion lines. After the collision, they are together. They are combined. So I'm just going to write the combined mass because they're moving the same way. So their combined mass now is 70 kilograms. And we want to find out what their combined velocity is. So we have conservation of momentum, which says that the total momentum in the beginning is equal to the total momentum at the end. And remember that momentum is mass times velocity. So what we'll do here is the mass times velocity of the person plus the mass times the velocity of the skateboard. The total momentum in the beginning is equal to the total momentum at the end. Now in the end, there's only one object moving together. So the skateboard and the person are moving together at the end, so there's just one thing moving. So just one m times v at the end. And we are supposed to find the velocity of the skateboard and the skateboarder together as the skateboarder lands on the skateboard. So we're going to write down our values. We're going to do our substitutions here. So we have 65 kilograms times 4.3 meters per second plus 5 kilograms times 0 meters per second. We see if we write our givens down as such, we can easily write this equation. However many there are, that's how many m times v's there are. So if there be 3 objects, we have 3 m times v's. If there be 4 objects, we have 4 m times v's. If there's just one object, we just have 1 m times v. But we just add them all together on the left equals all of them added together on the right. And since we wrote our givens down as such, it makes it easy to write the numbers in. 65, 4.3, 5, 0. On this side here, we have the mass is 70. It just makes it easier to work with. And then therefore easier to solve the problem. The key to physics is organization, really. It's really just organization. So now we can solve, and we get that this velocity with which they move together is 3.99 meters per second. And we want to stand back and see, does that make sense? As the skateboarder lands on the skateboard, the mass increases, and so therefore the velocity must decrease if momentum is conserved. So it would make sense that it would be less than 4.3, and that's what we got, 3.9.